about limits, specifically limits of a function. So the limit of a function. Now, we've heard the word limit in life a lot. If you think about it, you got speed limits, weight limits for a ride at an amusement park or something like that. And so like a speed limit, it's where you're supposed to be at, right? Could you go over? Yeah. Could you go under? Yeah. But that's your aim. Now, some limits are definite limits, like a weight limit, for a chair or something like that. You don't want to go over the weight limit or it'll break. But when we're talking about a limit of a function, what this is what we're trying to find out is what value is f of x approaching as x approaches some number. Let's call it a. And instead of writing all those words, what value is f of x approaching as x approaches a, we use a different notation. We use limits, and I tend to write L-I-M. I write it in cursive so it doesn't look, L-I-M, L-I-M, sometimes looks kind of weird. And we say as x approaches a of our function equals what? So this notation means what value is f of x approaching as x approaches a. And the subtleties in that language mean that I don't really care what happens at a. I'm looking as I approach a. So I'm going to start off with a really simple example. Let's say I have the limit as x approaches 4 of x minus 1. I don't really want to know what the output is right at 4. I mean, I'm kind of going for that. But what I want to know is what we're approaching. So what I'm going to do is make a little table. X and f of x. And we want to get really, really, really close to 4. So I'm going to put 4 right in the middle. I want to get really, really close to 4. Well, let's see. 3.9 is kind of close. Well, isn't 3.99 even closer? Wouldn't 3.999 be awfully close? I don't care what's happening right here. On the other side of 4, kind of going with that notation, maybe we go 4.001, 4.01, and 4.1. I want to know what y value I'm approaching. Now you could use a calculator. This is pretty easy. It's x minus 1. So this one's, I don't really need the calculator for it. It's going to be super easy. That's 2.9, 2.99, 2.999, 3.001, 3.01, and 3.1. So what is under the question mark? Well, it appears it would be a 3. So we would say the limit as x approaches 4 of x minus 1 is 3, because that's the y value that we're approaching. Second example. Now, first off, if I look at this one, could I plug in 2? Here I really could have plugged in 4. 4 minus 1 is 3. But here, 2 squared would be 4. 4 minus 4 is 0. 2 minus 2 is 0. I cannot directly substitute in that 2. I would get 0 over 0, which is like double bad. So I'm going to make a table very similar to what we did up there. And I want to pick x values that are getting closer and closer and closer to 2. So let's do something similar. Let's start with, say, 1.9. Then it would be at 1.99. Then it'd be at 1.999. Then at 2, I can't even get an answer. Then the other side would be 2.001, 2.01, and 2.1. Now for this, I might use a calculator. And you're welcome to use a graphing calculator if you like. I'm going to show you how you could use Desmos as well. So my function is x squared minus 4 over x minus 2. So I'm going to make a fraction. And if I show the keypad, oh, I thought it was in there. It's not. Miscellaneous. It does not have the fraction in there. Golly. Okay, so x squared. The way I'm going to do it is if I do parentheses around this, parentheses x squared minus 4 divided by, that gives me the fraction x minus 2. Keep that together. Now I can see the graph, but I don't really care about the graph. I'm looking at a table. So if you click this settings thing, you can convert this to a table. And you can type in the x values we want. So we have 1.9, 1.99, 1.999, and at 2, it won't even give me an answer. Oh, but I don't care about that. I care about what's happening on either side of 2. So I'm going to copy those answers over. That's 3.9. 3.99, 3.999, 4.001, 4.01, 4.1. So what should be right here? Well, it looks like it should be 4, but actually there's nothing there. What's happening on that graph is, if we looked at the graph, it just looked like a line, right? But it's missing the value at 2. It looks like it should go to 4, but it's not. I'm getting an undefined answer. And that's because it's going to have a hole in the graph. So I'm going to look back at that. It crossed here. So it looks like this. It has a hole in the graph. We just can't see it on a graphing calculator or on Desmos, because it's so pixelated and a point is infinitely small. But I can find out where it's going by looking at the table. So I would say that the limit as x approaches 2 of x squared minus 4 over x minus 2 is approaching 4. This is very, very different than saying f of 2 is 4. It is not. The function cannot be evaluated at 2, but we can figure out where it's approaching. Let's try one more. Let's see which one I want to use next. Oh, that looks like a good one. Okay. The limit as x approaches 3 of, actually let's make that a negative 3. Ooh. X plus 3 over x squared minus 9. Again, we're going to make our table. I decided on a negative x value because I wanted us to think about how that table would look. Negative 3 is going to be in the middle. Negative 3. Don't care what happens there, but what would happen there? Negative 3 plus 3. Negative 3 squared is 9 minus 9. It'd be a bad, bad number. Now remember how negatives work. This would be negative 3.001. This would be negative 3.01. And this would be negative 3.1. Over here would be negative 2.999, then negative 2.99, then negative 2.9. Again, I'm going to use Desmos to create the table. So I'm going to go back up here and change this to be x plus 3. Ooh, we get a nice hyperbola. And in the bottom, x squared minus 9. And I also need to change the table here. So I'm going to change that to be negative 3.1. Uh-oh. What's happening here? I'm getting decimals. Whoops. This was supposed to be 0, 1. There we go. And this would be negative 3, which is undefined. What does it look like it's approaching? It looks like it's approaching negative 0.166666. What would be that in decimal? 1.166666666. So I'm going to see if I can kind of narrow that down. Let's see, that's not 1/3. I'm going to make another, oops, didn't want to do that. I'm going to go down here. 0.1666. What would be that? Let's see. Well, 1/3 is 0.33333, so it's less than that. 1/5 is 0.2. Let's try 1/6. That's it. And we'll go over how we can get a little bit more exact there. I should have copied my table in so I have my proof. This was negative 0.164, going 3 decimal places because that's always a good thing to do. 0.166, and this would be negative 0.1667. Then on the other side is negative 0.1667. Negative 0.167, and then negative 0.17. So it is approaching, so I would say my answer, my limit as x approaches negative 3 of x plus 3 over x squared minus 9 is approaching negative 0.1666667, blah, 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 which kind of figured out was going to be negative 1/6. I'm going to do one more with the table. Actually, a couple more. That was number 3. This is number 4. The limit as x approaches 0 of x over the absolute value of x. So let's make a table. And we're trying to get really, really close to 0. So this would be like negative 0.9. Then negative, whoops, no it wouldn't. Oh, be negative 0.1, then negative 0.001, then negative 0.0001. Ooh, I got kind of backwards. And then it would have 0. And on the positive side, it would just be the positive version. It's 0.001, 0.01. Let's see what happens on this one. So I'm going to change the function to be x over, and you can go to the function here and look for absolute value, but actually it's right here. I apologize. And I'm going to change that to be absolute value of x. Okay, let's change our table. Negative 0.1, negative 0.001, negative 0.0001, 0, 0.0001, 0.001, messed up. Oh well, it's okay. And then 0.1. I put too many but look what's happening. When x is negative, I just get negative 1. When x is positive, I'm getting positive 1. And look at the graph. This is kind of a piecewise graph. It's got one piece down here at negative 1 and another piece at 1. So if I'm looking at my table, what value is it approaching right here? Well, one side's approaching negative 1. One side's approaching 1. So the way we would state this is since the left and right side, left side, right side, left and right side are approaching different numbers, the limit does not exist. And a lot of times we'll abbreviate that with DNE, stating that the limit does not exist. So if I was answering this question, the limit as x approaches 0 of x over the absolute value of x does not exist. Let's do a cosine one for fun. And we are going to be doing, when we use trig functions in here, we'll mainly be using radians. So you'll want to make sure that you're in radians. I'm basically going to be using the same table we had up here because we're going to 0. That should be, that's where I messed up. There we go. 0.001. Gosh, I'm having one of those mornings. Let's see what this, remember, I don't care what's here. I'm trying to get close to 0. So I'm going to come back up here. cosine of 1 over x. Ooh. I'm also going to check that I'm in the right mode. And over here, there's a little graph settings. You can check that you are in radians there, and I am. So I'm good there. But look at this graph. I'm going to zoom in, which I can do with my mouse. What is it doing? It looks like it's crazy. I need to clean out some of this table, but that's okay. We already kind of had this, even though I messed up on my numbers of zeros. Oh my goodness. Having one of those days. Let's make it match our table correctly. Negative, then positive, then positive, then negative. What if I did have the extra zeros in here? It's going negative, positive, negative, nothing, negative, positive, negative. It's back and forth all over the place. So what's going to happen as I get closer and closer to zero? So I'm going to zoom in even more. More. Does it ever settle down? Wow, it looks like it's solid there because it's going back and forth and back and forth and back and forth. This graph is, let me get back to my table. This was negative 0.84, then positive 0.86, then negative 0.95, and then it repeats on this side. This graph is oscillating. So the left and the right side, it's never settling down. So this is another example of something where we cannot narrow down what the limit is approaching because it's bouncing back and forth. So this is another example of a limit that does not exist. Notice how the table kind of helps me see that with the bouncing back